Right, good day, grade 10 learners. Welcome to our mathematics lesson. I'm Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Are you happy to be in the lesson? And I'm so happy, guys. On Thursday, every Thursday is my best day. Thursday is my best day. I know I'll be meeting you online and we'll be doing mathematics, okay? Right, are we ready for the lesson? Let's make sure that our books are there with us. Make sure your book is there with you. We're going to be writing, drawing triangles today. Make sure you have your ruler, you have your pencil, you have your eraser, everything. Make sure that your things are ready so that we move together. Let's do that. Let's do that. Let's do that. Grade 10s. Okay. Right. You want your work to be neat. You can even write the topic, special angles, write today's date, everything. Make sure that your work is neat. Okay. Right. Now, let's start. Right. By the end of the lesson, grade 10s, you should be able to what? You are going to derive. You are going to derive values of trigonometric ratios for special angles. Okay, without using a calculator. Who's going to derive? It's not me, it's you, grade 10s. Okay, it says by the end of this lesson, you should be able to derive. Okay, you are the ones who are deriving. So the whole lesson is going to be almost investigative. We're going to be moving together, isn't it? Right, I'll be telling you, do this, you do that, I give you an activity to try things, and then you must discover things. Oh, this thing is like this. Okay, this is how today's lesson is going to look like. Okay, right. So the special angles we're going to look at 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, right, we're going to be looking at these special angles. What are the trigonometric ratios for 0 degrees, for 30 degrees, for 45 degrees, for 60 degrees, and 90 degrees? For example, I'll say, what is tan 60 degrees? What is cos 45 degrees? What is sine 45 degrees? You must know those ones. You must know them. Okay, right. Now, you can refer to the CAPS document, page 23. Grade 8 and 9, we did topics that are going to assist us in today's lesson. We did triangles. We're going to be using triangles today, especially the right angle triangle and the equilateral triangle. I'll remind you about those two triangles. Right, we did the Pythagoras theorem. We're going to use it today. You see, this theorem is very, very popular in trigonometry. You see that? Okay, and then we have the trigonometric ratios now. You know what sine theta is, what cos theta is, and what tan theta is. Okay, those are the three trigonometric ratios. We're going to talk about them. And then we have squares, square roots, cubes, and cube roots. We're going to use our knowledge about these things in today's lesson. Right. Now, I want us to do this activity. I'm going to give you 2 minutes. I have 3 questions. Okay, this is question 1. I have question 2, I have question 3. This activity is baseline, but it is very, very, very important for today's lesson. For you to be able to do today's lesson or to understand what you're supposed to do today, you have to make sure that you understand this baseline activity, okay? Right, I want us to try these 3. This is our first question. And then for 2 minutes, and then after 2 minutes, we'll discuss. Try to simplify them. 2 minutes. Right, welcome back, Cretans. Welcome back. Don't forget our WhatsApp line, Cretans, 064 Don't forget, 064 Let's interact during the lesson, okay? As we move on, let's keep on discussing. If there are any questions, send them. If there's any input, send that input. It will assist us a lot, okay? Right, what did you get? Square root of 5 plus square root of 5. These are sets. They are called sets. Square root of 5 plus square root of 5. We treat these things like terms. If I say x plus x, what is x plus x? I know someone will say x squared. That's a common miss. I don't know why. Right. Remember, when you're adding like terms, just think of real things. I usually think about fruits, oranges. If I say 1 orange plus 1 orange, I get 2 oranges. You see that those are like terms, okay? Or 1 sweet plus 1 sweet is 2 sweets. So x plus x is what? Is 2x, isn't it? So now treat this thing also like what? Like you deal with like terms. What is root 5 plus root 5? What is it going to be? It's going to be 2 root 5. Do you see that? It's like terms, okay? B. What about root 3 plus root 5? Okay, let me give an example. I say x plus y or a plus b. What will I get? I'll get a plus b. Okay, if you say 1 apple plus 1 orange, you still have 1 apple plus 1 orange. You cannot combine them. They are unlike terms. So this one remains as it is. They are unlike terms. We see that. And then the last one, 3 root 2 minus root 2. Now someone maybe made a mistake, you're not sure, you want to try this thing. Can you do it fast before me? Right, what is 3 root 2 minus root 2? I can give you an example and say, if I use x, I say 3x minus x. What do you get if you say 3x minus x? Like 3x minus 1x, what is it? It's 2x, isn't it? Right. So now, what is 3 root 2 minus root 2? Have you corrected your answer? Okay, do you have this one now? 2 root 2. Good. Now, let's mark our work. If you got that one correct, this one correct. Maybe this one was wrong before, but now you corrected your work and you got it right. Mark your work. Mark you have done. You have done it well. Let's do it. Okay. Right. Let's go to the second part of our baseline activity. Remember, I said this baseline activity is very, very important for our today's lesson. Okay. Right. Second part. I'm also going to give you 2 minutes. Let's try. Welcome back, grade 10s. Are you done? Remember our WhatsApp line 064 748 8913. And remember to do your corrections, grade 10s, okay? Remember to do your corrections. You can do your corrections using a pencil. You don't need to write, just correct with pencil and then we move on, okay? As I give you the answers, just correct with your pencil there. Right, now, what do we do here? Root 2, square root of 2 times square root of 3. Right, we multiply these things underneath the root sign. It's going to be a square root of 2 times 3. Do you remember this rule? Okay, remember this, right? Square root of A times square root of B is just the same as square root of A times B. Don't forget that. Okay, don't forget that. So the square root of 2 times square root of 3 is just the same as square root of 2 times 3. Okay, so we're getting the square root of 6 like that. Okay, mark your work if maybe you didn't know about it. Now make sure you know that. Just make your corrections and write this rule or this law. Write it down. Okay, right. And then B, what is square root of 3 squared? It means we're saying square root of 3 times square root of 3, isn't it? When I'm saying x squared, it means x times x. If I'm saying 4 squared, it means 4 times 4, isn't it? So square root of 3 squared means square root of 3 times square root of 3, isn't it? Like this. Do you see that? And then using what we talked about here, you see this? We can say this is the square root of 3 times 3, and 3 times 3 is 9. See that? And then what is the square root of 9? Is 3. Okay, is 3. And then we write our answer, the 3 there. Okay, well, just take the positive one for now. Right, 3. Okay, and then the other thing you must remember, what happens to the square and the square root? Square and square root, what do they do to each other? They cancel each other out. Square and square root, they cancel each other out. Like here with the square root and the square, they cancel each other out. You remain with the x because they are inverse operations, okay? Remember that. Square and square root, they cancel each other out. Okay? So it means if I say square root of 2 squared, I must get 2. Or if I say square root of 2 times square root of 2, I must get 2 because square root of 2 times square root of 2 is square root of 2 squared, right? Even if I say square root of 3, I'm repeating the same thing here, is equals to 3. Remember that we're going to encounter this as we progress with our lesson, okay? Please make sure that your notes, you have them. You have these notes, we're going to use them as we progress with the lesson. Now, the last one, it may be a new concept, so I need to give you an example. And then after that, you'll do these two, okay? What is to rationalize the denominator? Right, let's say I have a fraction, which is, let me say, 2 over root 5, square root of 5. What is my denominator here? It is the square root of 5. And square root of 5 is irrational. Do you remember the numbers? Right, the type of numbers. We have irrational numbers and rational numbers. Okay, rational numbers, we're talking about natural numbers, the whole numbers, integers, terminating decimals, recurring decimals. Do you remember those? Okay, so now we want our denominator to be rational because now it is irrational. So if we want this one to be rational, to be root 5, we want to make it rational, we have to multiply it by square root of 5. Remember, what is square root of 5 times square root of 5? Like we just talked about this. Square root of 5 times square root of 5 is equals to 5. Let me write it down. Square root of 5 times square root of 5 is equals to 5. We talked about this, isn't it? Now, so I must multiply the denominator by square root of 5. But I can't just multiply the denominator only. Otherwise, my fraction will change. To make it an equivalent fraction, what I do to the numerator, I must do to the denominator. What I do to the denominator, I must do to the numerator. So I'm going to multiply this one by 5, square root of 5. I must also multiply the numerator by square root of 5 so that I have equivalent fractions. Okay? And then what you get, multiplying fractions is easier than even addition, because say numerator times numerator, denominator times denominator. So here it's going to be 2 times square root of 5, which is 2 root 5, square root of 5. And then over, what is square root of 5 times square root of 5, which is 5. You see that? Okay. Now the denominator is rational. Do you see that? I've rationalized the denominator. That's what we mean by saying rationalizing the denominator. It is very, very important. We're going to use this today. Just in 2 minutes, try to do A and B. And then after that, we mark our work. Let's try. Welcome back, grade 10s. Did you manage to get the answers? Let's mark our work. Let's mark our work. If you see that, okay, I made a mistake with my question A, now I understand. You want to correct your B, just do that. Okay, let's start with A. So our denominator is square root of 2. How can we make this one rational? Because it is irrational now. So we have to multiply by square root of 2. You see that? So, but we can't just multiply the denominator by square root of 2 and leave our numerator on its own like that. We also need to multiply our numerator by square root of 2. Okay, so we do it like this. So, and then we say numerator times numerator, and then denominator times denominator. Now our denominator is rational. You see that? We have rationalized our denominator. It does not mean that these two things are different. If you want, you can check with your calculator and see if you write it as a decimal, what you get. This and this is just the same thing. It gives you the same value. You can try that. Just put in your calculator and then write it is, display it as a decimal. And then you do the other one, display it as a decimal. You'll see they are just the same things. Okay? Right, B. B, what did you do? We multiply the numerator and denominator by what? By the denominator, which is square root of 3. So it's going to be square root of 3, 2 times square root of 3, which is 2 root 3. And then square root of 3 times square root of 3 is 3. Here you can see that we have rationalized our denominator. Okay. So we have done our baseline activity, grade 10s. Now we need to go to our special angles, and we're going to apply our knowledge about what we have done in the baseline activity, and also our knowledge about triangles, especially the right angle triangle and the equilateral triangle. We are doing this together. The activity that I have is at the end. So the whole lesson is an activity. I'm going to be asking you to do things, okay? Right. Now, special angles, we said, is 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So we're going to find trigonometric ratios for all these angles. So we're going to find, let's say, for example, let me pick 30 degrees. We're going to find sine 30 degrees, cos 30 degrees, tan 30 degrees. Okay, for all of them. Right, so now let's start with angle 45 degrees. Write down angle 45 degrees. Write it down. Right, angle 45 degrees. We're dealing with angle 45 degrees. How do we derive the ratio for this angle? You've written that angle 45 degrees. Okay, right. Now, consider triangle ABC, where BC is equals to 1 unit, AB is equals to 1 unit, and angle B is 90 degrees. Okay, I want you, don't write the sentence or the text part, just draw triangle ABC. I'm going to give you 1 minute to draw triangle ABC. We're going to be adding information to this triangle. Okay, we're not going to be drawing different triangles, just on this one, and then we'll be adding information onto it. Right now, draw triangle ABC for 1 minute. Please take note, your AB is 1 unit, so the 1 must be there here. And then BC is 1 unit, write that. And then this right angle, B there, right angle, this right angle, make sure it is there. Okay, let's do that for 1 minute. Welcome back, grade 10s. Did you manage to draw a diagram? I was also drawing mine here, but I don't have a ruler. Please don't draw using freehand. Use your ruler so that your work is neat. Okay, you see, mine is not neat here because I didn't use a ruler. You see, but I tried. Okay, right. Now, we're going to be adding information to this triangle. What type of a triangle is this? We said is what? It's a right angle triangle. Right angle triangle. When we talk about right angle triangle, grade 10s, what theorem comes to your mind? There's a popular theorem. What theorem? The Pythagoras theorem. Good. The Pythagoras theorem. If you see a right angle triangle, grade 10s, just know. You must know mathematics. When you see something, just think, okay, there must be Pythagoras here. It's a right angle triangle. Must be Pythagoras theorem here. Okay? Just know that. Now, what does it say? What does it say? Right, I want you to try that before I show you, okay? So now I want us to find, or before we go to the Pythagoras theorem, sorry for that. Now, if we check AB is 1 unit, we'll come back to the Pythagoras theorem. AB is 1 unit, BC is 1 unit. What type of a triangle is that? Where we have two sides that are equal. It's an isosceles triangle. You see that? Now, I want you to try to find the size of angle A and angle C. We know angle B is 90 degrees, okay? I'm going to give you 2 minutes. Try to find angle A and angle C. ABC is an isosceles triangle. It's a right-angled triangle, also an isosceles triangle. Try to find angle A and C. Yeah, the clue is there. Welcome back, grade 10s. Welcome back. Thank you very much, Jablani Technical Secondary School. We're getting input from you. Thank you very much for interacting with us, and also other schools that are interacting with us, giving us input. That makes our lessons improve, and also we assist each other. Okay, thank you a lot. Right now, find the size of angle A and angle C. Right. We said ABC is an isosceles triangle. What do you know about an isosceles triangle? Let's do it together. So angle A is equals to angle C. Why is angle A equal to angle C? Because they are angles opposite equal sides. BC and AB are equal. Okay, right, it means they are equal. Now we can say angle A or angle C is equals to 45 degrees. I think this one I move a bit fast. Let me show you nicely. Right, we'll say angle A plus angle B plus angle C is equals to 180 degrees because the angle sum in triangle. Right. And then we know that angle A is equals to angle C. And B is given. B is 90 degrees. So now we can say angle A plus angle C. Let me put A and C next to each other. Plus 90 degrees equals to 180 degrees. Do you see that? Okay. B is given. Is 90 degrees. And then we can transpose it. It becomes, and A is equals to C. Let's say, but angle A is equal to angle C. So we can say 2A because A plus A. Okay, A plus A is 2A. So it's 2A. You see where the 2A is coming from? Because C is equal to A, so is equals to 180 minus 90. You see that? And then we divide both sides by what? By 2. Divide both sides by 2. And then do you see where this thing is coming from? Okay. So it means angle A is 45 degrees and angle C is 45 degrees. I want you to, the diagram that we drew, can you write angle 45 degrees, 45 degrees for A and C? Let's just write that. I'm not going to go anywhere. Just waiting for you to write. Angle A, 45, right? 45 degrees. Angle C, right? 45 degrees. Don't draw another triangle. Just one triangle that we're going to use. Right. We keep on adding information to that triangle. Right? Everyone should be done now. Let's go to the next step. Now we have our angle is 45. Do you see? I said you had a clue because we're talking about angle 45. Now let's go to the next step. We said it's a right angle triangle. Which theorem? Pythagoras. Now I want you to calculate the length of the side AC. What type of a side is AC? It's opposite a right angle. It is the hypotenuse. So AC is the hypotenuse. Let's try to find the side of the length of the side AC using the Pythagoras theorem. Let's try for 2 minutes. Right, welcome back, grade 10. Did you manage to get what AC is? How many people got square root of 3? If you got square root of 3, well done, well done, well done. But even if you tried, guys, it's not about getting the correct thing. It's about trying. Okay, making our mistakes, we correct our mistakes. That's learning. That's learning. So now, and then we have AC, which is our hypotenuse. AC squared is equals to AB squared plus BC squared. Remember, grade 10s, Euclidean geometry is always statement, reason. Statement, reason. Okay, we can't just say A squared is equals to AB squared plus BC squared. Why are we saying that? We have to put a reason for that. So it's because of the Pythagoras theorem. Right now, let's substitute what we have. Our AB is 1, so it's going to be 1 squared. I made a mistake. I said the answer is 3 squared. I think I made a mistake here. Okay, right. It should be square root of 2. Square root of 2. Right, 1 squared. AB is 1 squared. We see we substituted here. We substitute. Usually say what we substitute must put in the brackets. Ne? Okay. Right. So AB, we put 1. BC, we put 1. Okay. So what is 1 plus 1? That's 2. That's 2. Okay. And then what do we do to get AC? What's the inverse of squaring? We talked about this. The inverse of squaring is what? Square rooting. So we square root both sides. We square root. And then the square root and the square, they what? They cancel each other out. We remain with AC is the square root of 2. Please make correct that. I said square root of 3 should be square root of 2. Square root of 2. And then let's go back to our diagram. Let's go back to our diagram. Where there is AC, we put square root of 2. Okay. Right. We are deriving the ratios. Remember that. Okay. So AC is the square root of 2. Sorry. I like square root of 3. I don't know why. Right. Now, if you look at, let's make this one our reference angle. If you look at the angle 45, which one is the opposite side? It's BC, which is 1, isn't it? Which one is the adjacent side? It's AB, which is 1, isn't it? Which one is the hypotenuse? Is AC, which is square root of 2, isn't it? Okay, good. Now, I want us to use our triangle now to write our 3 trigonometric ratios. Sine 45 degrees, cos 45 degrees, tan 45 degrees. How many people remember the acronym that we use? We use SOHCAHTOA. Is it called the acronym? Okay. Sine theta is what? Opposite side over hypotenuse side. Okay. Cos theta in this case is 45. Cos 45 is going to be adjacent side over hypotenuse side. And then tan 45 is going to be opposite side over adjacent side. Remember that. I want you to do this in 1 minute. We are running out of time. 1 minute. Now use your triangle and write your 3 trigonometric ratios for sine 45, cos 45, and tan 45. 1 minute. Welcome back, grade 10. Did you get the answers? Sine 45. You can pick, even this one is going, they're going to give us the same answer. Even this one, they're going to give us the same answer. Sine 45, opposite over hypotenuse. Opposite side over hypotenuse. Opposite side is 1, hypotenuse is square root of 2. So it's going to be 1 over square root of 2. I want you to first put it in your calculator Just say sine 45 and say equals. What do you get? Sine 45 with your calculator first. Sine 45, what equals? What do you get? Do you get 1 over square root of 2? You're getting something different, isn't it? Okay, but why is it different? We are getting the answer like this, isn't it? Root 2 over 2. Why are we getting that? What did the calculator do? The calculator rationalized the denominator. Okay, the calculator rationalized the denominator. Remember, we said we can rationalize our denominator. 1 over root 2 is times root 2 over root 2, like that. And then 1 times root 2 is root 2. Root 2 times root 2 is 2. So the calculator will always rationalize our denominators. Okay, right. So there's nothing wrong there. Okay, we just from this to this, we rationalize the denominators. Okay, so cos 45, I want you to write your ratio, and then after that, rationalize it and see, get your final answer. Cos 45. If you have your answer, try to rationalize it first. Okay, have you managed? Right, cos 45 is adjacent. AB is adjacent, which is 1. Hypotenuse is square root of 2. So again, 1 over square root of 2, we rationalize it, is square root of 2 over 2. What can you say about sine 45 and cos 45? They are the same. Cos 45 and sine 45, they are the same. Right, tan 45. Tan 45 is opposite over adjacent. So it's 1 over 1. Okay, so tan 45 is equals to 1. Done. So we found the 3 trigonometric ratios for angle 45. Now we need to go to angle 30 and angle 60 degrees. Okay, right. Angle 60 degrees and 30 degrees. Right, consider the triangle, the equilateral triangle ABC, where AB is 2 units, BC is 2 units, and AC is 2 units. Right, I want you to draw triangle ABC. Right, 1 minute, draw triangle ABC. Let's try. And then we're going to be adding information to this triangle for 1 minute. Welcome back, grade 10s. Welcome back. Now, what have we done so far? We have derived the trigonometric ratios of angle 45 degrees. We now know that sine 45 is root 2 over 2, cos 45 is root 2 over 2, and then tan 45 is 1. You must know that. Okay? Special English, you must know them. Right. We used a right-angled triangle to prove that. A right-angled triangle, which is isosceles also, to prove that. Okay? Right. Now we want to derive. Okay, so we're not proving but deriving. We want to derive the ratios for sine 60 degrees and, for 60 degrees and 30 degrees, where you're going to use an equilateral triangle. Let me try to fill in the angles and the sides because of time. I wanted you to find the angles, draw the height, and all those things, okay? But some things I'm going to be asking you to do. So try to listen, and then I'll ask you to do some of the things that, okay, because of time. So now, what do we know about an equilateral triangle? All the 3 angles are equal, and each angle is 60 degrees. Do you know that? right? And all the three sides are equal. That's an equilateral triangle. Remember, angles in a triangle add up to 180 degrees. So it's going to be 60 degrees plus 60 degrees plus 60 degrees, which will give you 180 degrees. So each angle is 60 degrees. I wanted you to do that, but let me just show you right now. So the A is 60 degrees, B is 60 degrees, and then C is 60 degrees. Let's write on our diagram. Let's write these angles. A 60 degrees. Let's do that. I'm not going to give you time. Just do it. A 60 degrees, B 60 degrees, C 60 degrees. Make sure you have your diagram. Without the diagram, you won't understand. Let's have those three angles. Okay. Right. So I'm not going to explain the part where you're saying A. How do we find the 6 degrees? I've explained that, okay? I'm not going to show you now from here. So now we have our 6 degrees in our three angles. Right, let's go to the next part. Now we're doing a construction, okay? We're doing a construction. Right, I think I'm moving fast. Let me just slow down a bit so that we understand. It is very, very important that whatever we do, we understand. But now, if there are any questions on what I've covered, please send us the question. I've said our angle A is 60 degrees, our angle B is 60 degrees, and our angle C, angle A 60 degrees, angle B 60 degrees, angle C 60 degrees. Right. Now we're going to do a construction. I want you to construct the height from A, right, like this. Draw a line from A up to the line BC, and it must be perpendicular to BC. Indicate that with this angle here. Let's do that. Okay, let me just give you 1 minute so that you can catch up if maybe being left behind. 1 minute. Draw the line and then indicate the 90-degree angle there. Let's do that for 1 minute. Welcome back, grade 10s. I'm so happy people are participating. Thank you very much. Well done, well done, well done. Let's continue doing our best. Okay, right. We're seeing a lot of participation from Begilanga Secondary School, Jetinteo Secondary School, and other schools. Please, let's try our best and then we learn. Okay, right now, we have drawn our height. Right. So now, so it means it's dividing BC into two equal parts. So it means BD is going to be 1 unit. BD is going to be 1 unit. DC is going to be 1 unit. Can you add this to our diagram? BD is 1 unit. DC is 1 unit. Just add those ones there. BD is 1 unit. DC is 1 unit because that height is dividing BC into two equal parts. Right. And then what will be these angles here? What do you think this angle is going to be? This one and this one. What are they going to be? Okay. Remember this one is 90. This one is 90. This one is also 90 there. Okay. So it's going to be 60 plus 90, which is 150. And then we must get 30 here, isn't it? Because they must add up to 180 degrees. How many triangles maybe do you see? Let me just go to that. You see, there's this triangle, the big one. Let me draw it. You see the triangle ABC, the big one. Okay. And then inside the big triangle, we have small triangles there, right angle triangles. Do you see them? Let me use different color. You see this one? It's a right angle triangle there. Do you see that? Okay. And then there's another one. This one. You see that? You see this one? It's another one. You see? There are two right angle triangles there. There's ABD and ADC. You see that? So this angle here, what is it going to be? And then this angle here, what is it going to be? This one. You see? They're going to be 30, isn't it? Because it's 60 plus 90 plus 30 plus 30, they will give us 180 degrees, okay? Right. So there will be 30 degrees. I'm just telling you this because of the time. So that angle there is 38. B80 is 30 degrees. And then C80 is also 30 degrees, okay? Now, can you add these angles 30 degrees to your diagram? Just add this angle 30 degrees there and add this angle 30 degrees there, okay? For 30 seconds. I'm going to wait here for you. 30 degrees, 30 degrees, then we move on to our ratios. Okay? Remember WhatsApp line 064 748 8913. 064 748 8913. Okay? Right, we have our angles now. So, let's look at one right angle triangle. Let's check this one. There's something missing here. Let's look at our angle 60 degrees. Do we have a side adjacent to angle 60 degrees? What is that side? It's BD, which is 1, isn't it? And then do we have the hypotenuse for triangle ABD? Yes, we have the hypotenuse. It's AB. Do we have the opposite side to this angle? Do we have the opposite side? AD is opposite. AD. Do you see AD is opposite? But now it's empty. We don't know the size of AD. So what do you think we must do? We must find the size of what? Of AD. What theorem are we going to use? ABD is a right angle triangle. So what theorem are we going to use? The Pythagoras theorem to find AD. Okay, now let's try to move together. Let's try to move together so we can finish our lesson. Right, so it's AD. We're going to find AD using the Pythagoras theorem. Do you see that? Now, let's find AD together. Right. Now, the Pythagoras theorem, what does it say? Let's concentrate on this triangle. Let's concentrate on this triangle. Okay. Right. What are we going to do? Or even this one. I think I used this one. Yeah, I think I used this one. No, it's fine. It's okay. Right. If we use this side, it's still okay. The one which is not shaded, this side. Right. Now, let's use the AC one. So it's going to be AC squared is equals to what? Is equals to AD squared plus DC squared. Okay? You see that? But now we know what AC is. AC is 2. It's going to be 2 squared is equals to 80. We don't know 80. Oh, sorry, I forgot the reason. Why am I saying Pythagoras? Right, it's going to be 80 squared plus DC is 1 squared. You see that? Okay? That's the Pythagoras theorem. Okay? Right, so that's the Pythagoras theorem. So now what I've done here, you see my subject of the formula there is 80 squared. What have I done? We transpose this. It becomes AC squared minus DC squared is equals to 80 squared. You see that? That's the Pythagoras theorem. We want to find 80. Remember, the Pythagoras theorem does not change. You may be looking for any side which is not the hypotenuse. It does not mean that you must change the Pythagoras theorem. It's always hypotenuse squared is equals to one side squared plus the other side squared. Don't forget that. Okay? So now that's why we are here now with the Pythagoras theorem. Now let's substitute. Okay, AC is 2 squared, and then DC is 1 squared. So it's going to be 4 minus 3, isn't it? 4 minus 3, so it's going to be 8D squared is equals to 4 minus 3. What is 4 minus, what am I saying? 4 minus 1, 4 minus 1, sorry learners, 4 minus 1, 4 minus 1, okay? 4 minus 1, which is 3, okay? 4 minus 1, which is 3, right? And then what do we do to get 80? What do we do? We square root both sides. We square root both sides. We square root both sides. And then that we get that 80 is square root of 3. Now, to our diagram, write the value or the size of 80 square root of 3. Let's do that. Just add square root of 3 to your diagram. Okay? Please, if you need time, just tell us. Square root of 3 to your diagram. Okay, if you want to write notes, just short notes, because we won't have enough time to write everything. Okay, right. Now you must be having a diagram like this one. Please, may have a diagram like this one. Make sure your diagram is like this, with BD is 1, DC is 1, AC is 2, AB is 2, AD is square root of 3. Angle B is 60 degrees, angle C is 60 degrees, angle BAD is 30 degrees, BAD I mean this one. And then angle DAC, which is this one, is 30 degrees. Make sure that the things that I've mentioned are there on your diagram. Okay? Right. I want to erase this thing so that it doesn't disturb us. Okay, good. Now we're not going to be disturbed. Let me see if my pen is okay. Perfect. Right, now we can close one of the triangles and concentrate on one triangle, isn't it? Because so that we can have our 3 trigonometric ratios. You can even use a piece of paper to cover the side, one side like this. Okay, I'm going to cover mine like this. Do you see? Then I remain with my right angle triangle. Whichever, you can choose any side. Even if you choose the other triangle, it's still okay. We're going to get the same answer. Right, you cover it like this. Okay. Now, if you check here, we have our sides, opposite side, hypotenuse, and adjacent side. So now, we're going to concentrate on angle 30 degrees, this one. I want you to write the 3 trigonometric ratios. Sine 30, opposite side over hypotenuse. Cos 30, adjacent side over hypotenuse. And then tan 30, opposite side over adjacent side. Let's try that for 1 minute. Right, welcome back, grade 10s. Did you manage to get the 3 trigonometric ratios? Sine 30, opposite is 1. Hypotenuse is 2, because opposite side is this one here, this side, DC. Hypotenuse is AC. So sine 30 is 1 over 2. Okay, did you get it right? Mark that. Cos 30, adjacent, the side next to the 30 degrees. That's square root of 3. And then hypotenuse side is 2. So cos 30 is going to be square root of 3 over 2. Okay, mark that. And then tan 30 degrees, opposite side, which is 1, Am I right? And then adjacent side, which is square root of 3 there. Right. So it's going to be 1 over square root of 3. And then we rationalize the denominator. We get square root of 3 over 3. Because we rationalize the denominator. Do you see that? So now we have sine 30. Okay. Let's go back to what we did. We said cos 45 root 2 over 2. Sine 45 root 2 over 2. Tan 45 1. Cosine 30 1 over 2 half. Cos 30 root 3 over 2. And then tan 30 root 3 over 3. You see, we have derived all these trigonometric ratios for special angles. We're left with which one? 60 degrees. Let's go there. Now close any triangle of your choice. Choose one. You can choose the one on the left, the one on the right. It's still okay. We're going to get the same answer. I'm going to close this one this time. I'm going to close this one now this time. Let's write our 3 trigonometric ratios for our 60 degrees. Right. And then this is the 60 degrees. Let's have our 3. 1 minute. Right, welcome back, grade 10s. Welcome back. Let's have our answers. We're going to finish our lesson at 5 past 10, okay? Right, we got those 5 minutes. Right now, sine 60 is opposite over hypotenuse. Opposite this side. Hypotenuse 2. So it's going to be root 3 over 2. Mark that. And then cos 60, adjacent over hypotenuse. So it's going to be 1 over 2. Do you see that? Okay, right. And then tan 60 is opposite. Opposite is this right. The AD opposite. And then adjacent BD there. So it's going to be root 3 over 1. What is root 3 over 1? It's root 3. We have derived all the trigonometric ratios for special angles. Okay, we're left with 0 degrees and 90 degrees. I'm going to show you that in the summary. Okay, right. Now, this is the activity. I want to emphasize this on this activity. I'm going to tell you what to do. It's no longer an activity now. I'm going to teach you. Please listen and take notes. Okay, it is very, very easy to deal with special angles. They say without the use of a calculator. What does that mean? It means that you must show the ratios of the trigonometric ratios. Of the ratios of the special angles. Just show that. You're getting all your marks. Okay? Right. You can even confirm with your calculator. Confirm. I forgot. Cos 60 is what? Is it root 3 over 2? Was it 1 over 2? Let me confirm. You confirm. Put your calculator aside. Okay? And then you write the ratio. The ratio for cos 60 root is what? 1 over 2. You're getting a mark for writing 1 over 2. You're getting a mark for free. From this to this, you're getting a mark. From this to this, you're getting a mark. Just writing that. Don't just put everything in the calculator and then say the answer is root 3 over 4. You are not going to get anything. Okay, grade 10s, get the marks. The marks for trigonometry are coming from these things, small things that we do correctly. You find that the question has got 4 marks. Even if your final answer is wrong, it's wrong sometimes. I'm not encouraging you to do wrong things. You may find that you get 3 out of 4 or 5 out of 6. Because the small things that you do, you are doing them correctly. So don't lose marks. Special angles without the calculator, we want to see those ratios. Sine 60 is root 3 over 2, write it. And then after that, you simplify. You're getting your 3 out of 3. Okay? Sine squared 30. Okay, this one, I always say this is just the same as sine 30. If I put it like this, you understand better. Plus cos 60 squared. That's what it means. So inside the bracket, you have your sine 30, which is half. Inside the bracket, you have cos 60, which is half. Okay, 1 over 2. And then you have something like this. You see that? For writing this, you're getting a mark. 1 over 2. From cos 30 to 1 over 2 is a mark. From cos 60 to 1 over 2 is a mark. You can confirm your things using your calculator. Because sometimes even me, I forget. I just confirm. Oh, cos 60 is what? Okay, then I confirm. Then I put it aside. And then I do my things. I write everything. For simplifying here, I get a mark. For the answer, I get a mark. You see that? That's how you gain marks from what? From these trigonometric things. Okay? Right, let's summarize our lesson. Then we'll be what? We'll be done. We're going to finish at 5 past. Right, sine 0 is 0. That's a special angle. We didn't talk about it, but we can talk about this one using the Venn diagram, but we're not going to have time to discuss the Venn diagram. Right, cos 0 is 1. Remember that. And then tan 0 is 0. Okay. So the only trigonometric ratio, the ratio that will give you 1 here is cos 0. Okay. Then we did this one. Sin 30 is 1 over 2. Cos 30 is root 3 over 2. Tan 30 is root 3 over 3. Okay. And then we said sin 45. Okay. We said root 2 over 2 here after rationalizing. Root 2 over 2. And then tan 45 is 1. Sin 60 is root 3 over 2. Cos 60 is 1. And then tan 60 is root 3. Okay. So remember these special angles. Okay. Thank you very much, grade 10s, for your time. And continue doing your best and continue being well behaved. We're going to meet next week for our next lesson. Goodbye.